In this video we're going to be learning about circles and ellipses. Let's start by defining the distance between 2 points. Let's say we have a plane and we are given 2 points, the first one called P and with coordinates x1, y1, and the second one called Q with coordinates x2, y2. And let's say we want to calculate this distance between them. The first thing to notice is that the point P has coordinates x1, y1, which means that this number here is x1 and this number here is y1, and Q has coordinates x2, y2, so this number is x2 and this number is y2. So what we can do now is form a triangle with this pink side and this green side. And now we can use the Pythagorean theorem, and this square is going to be equal to the square of the green distance plus the square of the pink distance. So think about what the pink distance is. Let's say we have all this. This segment has a measure of y1. And now what we want to do is remove this part here, and this part is y2, and we are removing y2 to y1. So this distance is going to be y1 minus y2. And the same here, we have this distance is x2 and we are removing this part here, that's x1. So then this green distance is going to be x2 minus x1. So now we use Pythagorean theorem and we'll get that this square is going to be equal to the square of the green distance, that is x2 minus x1 squared, plus the square of the pink distance, that is y1 minus y2 squared. Let's work a bit on this formula. This squared is going to be equal to x2 minus x1 squared plus, and this number as it is squared, it can be rewritten as y2 minus y1 squared. So now t is going to be the square root of all this expression. And we got to the expression of the distance formula between x1, y1 and x2, y2. And with this information, we're ready to work on the circle. The definition of a circle is, given a point we're going to call the origin and a radius we're going to call r, a circle is formed by all the points that are equidistant with distance r to O, and it looks something like this. To get the formula for a circle, let's suppose the circle is centered in the 0, 0. So O has coordinates 0, 0. And now let's take a point P with coordinates x and y. We want to calculate the distance from P to O. Well, as P is a point in the circle, this distance is r. As before, because P has coordinates x, y, that means that this point is x and this point is y. So again we can form a triangle. Using the Pythagorean theorem, we can now say that r squared is going to be equal to the distance between P and the origin. So in the x-axis we have x minus 0 squared plus, and in the y-axis we have y minus 0 squared. So we got that r squared equals x minus 0 squared is x squared plus y minus 0 squared is y squared. And this is the equation of a circle with center in the 0, 0. Let's see what happens now when the circle is not centered in the 0, 0. So let's assume we have a circle here with origin O that has coordinates h, k. Now let's take a point here, P, with coordinates x, y. Again, we're going to be saying that this circle has a radius r, and we want to calculate the distance between O and P. This distance, as before, is going to be the radius. But what we're going to do is express this radius in another way. So for this, we're going to say the origin has coordinates h, k. That means that here this number is h and this number is k. P has coordinates x, y, so this number here is x and this number is y. As before, this distance is k minus y and this distance is x minus h. So we can form our triangle with green and blue sides and use the Pythagorean theorem to say that r squared is going to be equal to the green distance, that's x minus h squared, plus the blue distance, k minus y squared. So working a bit on this formula, we have x minus h squared plus, we can write this as y minus k squared. And this is the equation of a circle with center in hk. Let's do an example. We are given the expression x minus 3 squared plus y plus 2 squared equal to 4. We want to draw this circle. Let's remember the equation of a circle with center in hk. We can rewrite our equation as this: x minus 3 squared plus y minus 2 squared. This is important because the equation of a circle has a minus sign here, and here we had a plus sign. So we transformed our plus into the multiplication of two minuses. So with this, we can now say that 3 is going to be h, that minus 2 is going to be k, and that 4 is going to be r squared. So this tells us that 2 is going to be r. So what we have here is the equation of a circle of radius 2 with center in 3 minus 2. Let's draw this circle. We have the axis, and we know the center is in 3 minus 2. it's going to be this point. We also know that our circle has a radius of 2. That means that this line is the radius. So the circle is going to have this point, also this one because it's a distance 2, this one, and all the points in between. So it's going to look something like this. Let's continue working now with ellipses. An ellipse is defined as given 2 points, we're gonna call focus points, is formed by all the points for which the sum of the distances between the point and the focus points is constant. So given 2 points, focus point 1 and focus point 2, if we take a point in the ellipse, this point is at distance blue from the first focus point and at distance green from the second focus point. The idea is that whenever we take another point, the distance green plus blue is always the same. So if I take a point here, this point is gonna have blue distance here and green distance here, and the ellipse looks something like this. If I take a point here, this point is at blue distance here and green distance here. We are adding this segment twice, with the blue distance once and once again with green. And then we are adding this middle segment. And this sum of green plus blue is constant for all the other points in the ellipse. And that's why in the video where we developed the formula for the ellipse, we said that this distance, the distance blue plus green, was constant and equal to 2a. And a is the distance from the origin of the ellipse to this side. The sum has to be the length of this segment, and this segment is 2 times a. When we have an ellipse that is centered in the 0, 0, let's say our ellipse looks something like this. It's centered here and it has 2 focus points in minus C0 and in C0. We just said that this point was going to be the A0 and this one minus A0. And we call this point 0B and this one 0 minus B. In another video we derived the formula for the ellipse and it was x squared over a squared plus y squared over b squared equal to 1, where b squared equals a squared minus c squared. This is the equation of an ellipse with focus points in minus c0 and c0 and centered in the origin. When we move our ellipse, and it's now no longer centered in the 0, 0, so we have our axis and let's say we have an ellipse here with center with coordinates h, k. We have the 2 focus points f1 and f2. And what we're gonna do is call this distance c. f2 here has this distance is c and this distance is h, because here is the origin. So F2 has coordinates h plus c, y coordinate is k, because it's the same one as the origin. F1 is also a distance c from the origin. So for F1 we have h minus this segment here, so this is h minus c, and vertically again k. Now let's think about something we studied in previous videos. When we had something that was centered and we wanted to move it vertically or horizontally, what we would do is, in this case, we're moving it to the right h units and upwards k units. The way this shifts influence our formula is we have to subtract h from x and subtract k from y. And like this, we reach the equation of an ellipse with center in hk. Let's do an example. We are given this equation. We want to try and draw the ellipse this equation represents. First, let's take common factor 4 from the first two terms. This leaves us with 4 times x squared minus 4x. And from the two last terms, let's take common factor 9. This will be 9 times y squared plus 2y. And this all equals to 11. Now, we can rewrite this adding 4 here. Let's say we add 4. We're actually adding to the whole equation 4 times 4. So we are adding 16. Now in this side, we can also add 16 so the equation sustains. And we have 9 times y squared plus 2y. And now here I can add 1. But actually to the whole equation I'm adding 9 times 1. So again on this right hand side I add plus 9. And the equation sustains. Now I'm gonna work on this parenthesis and then on this one. So I can rewrite this as 4 times x minus 2 squared plus 9 y plus 1 squared. And this will all equal to 11 plus 16 plus 9, that is 36. Now if we remember from the equation of an ellipse, we had a 1 on the right hand side of the equation. To try and get that 1, we're going to divide this expression by 36. So we're going to have 4 times x minus 2 squared divided by 36 plus 9 times y plus 1 squared divided by 36. This is equal to 36 over 36. 4 divided by 36 is 1 over 9. And 9 over 36 is 1 over 4. 36 divided by 36 is 1. And now we have to remember the equation of the ellipse. And our equation can be written as this. And with all this information, we can now start plotting. Before plotting, I'm going to make a list of all the elements we have. We know that this equation is from an ellipse. It has its origin in hk, so this is in -2, -1. A, this big number that divides x, is gonna be equal to 3. B, the number that divides y, is gonna be equal to 2. And once we know a and b, we can calculate c, because b squared equals a squared minus c squared. So then c squared equals a squared minus b squared. And this is 3 squared minus 2 squared, which equals to 9 minus 4, 5. So then c is the square root of 5. And now when we go back to the plot, we had that the focus points were in h plus c, k, and h minus c, k. So in this case, our focus points are going to be h minus c, k, h plus c, k. H is 2, and c is square root of 5, k is -1. And the other focus point is going to be in 2 plus square root of 5 -1. Now with this information, let's draw the ellipse. Let's start with the origin. It is in 2 minus 1. Now the focus points are in 2 minus the square root of 5, that is something like 0.2 minus 1. So here is one of the focus points, and the other one is in 2 plus square root of 5, that is 4.2 and -1. We know that a equals 3. So from the origin, we can move 3 units to the right here, and this is where we'll have a. This is going to be in 5 minus 1. This is going to be the limit of the ellipse. And the same when we move in the negative direction, -3. So the other extreme point is going to be in -1, -1. P is equal to 2. So from the origin, we move 2 units upwards and 2 units downwards. And we get to the points 2 minus 3 and 2, 1. And with all these points, we can now draw the ellipse. It's gonna look something like this. And with this, we finish this video.